Two triangles are congruent if one coincides with, fits perfectly over, the other. In Figure 3.1, we say that triangle ABC is congruent to triangle DEF if these congruencies hold. Angle A is congruent to angle D. Angle B is congruent to angle E. Angle C is congruent to angle F. And line segment AB is congruent to line segment DE. Line segment BC is congruent to line segment EF. And line segment AC is congruent to line segment DF. From the indicated congruencies, we also say that vertex A corresponds to vertex D, as does B to E and C to F. In symbols, correspondences are represented by A, double arrow D, B, double arrow E, and C, double arrow F. The claim triangle MNQ is congruent to triangle RST orders corresponding vertices of the triangles, not shown. So we can conclude from this statement that M corresponds to R, N corresponds to S, and Q corresponds to T. This correspondence of vertices implies the congruence of corresponding parts, such as angle M is congruent to angle R, and line segment NQ is congruent to line segment ST. Conversely, if the correspondence of vertices of two congruent triangles is M corresponds to R, N corresponds to S, and Q corresponds to T, we order the vertices to make the claims. Triangle MNQ is congruent to triangle RST. Triangle NQM is congruent to triangle STR, and so on. For two congruent triangles, the correspondence of vertices is given. A corresponds to D, B corresponds to E, and C corresponds to F. Complete each statement. A. Triangle BCA is congruent to question mark. B. Triangle DEF is congruent to question mark. Solution. With due attention to the order of corresponding vertices, we have A. Triangle BCA is congruent to triangle EFD. B. Triangle DEF is congruent to triangle ABC. Definition. Two triangles are congruent if the 6 parts of the first triangle are congruent to the 6 corresponding parts of the second triangle. As always, any definition is reversible. If two triangles are known to be congruent, we may conclude that the corresponding parts are congruent. Moreover, if the 6 pairs of parts are known to be congruent, then so are the triangles. From the congruent parts indicated in Figure 3.2, we can conclude that triangle MNQ is congruent to triangle RST. Triangle TSR is the reflection of triangle QNM across a vertical line, not shown, that lies midway between the two triangles. In Figure 3.2, there are some of the properties of congruent triangles. Number 1. Triangle ABC is congruent to triangle ABC, reflexive property of congruence. Number 2. If triangle ABC is congruent to triangle DEF, then triangle DEF is congruent to triangle ABC, symmetric property of congruence. Number 3. If triangle ABC is congruent to triangle DEF, and triangle DEF is congruent to triangle GHI, then triangle ABC is congruent to triangle GHI, transitive property of congruence. On the basis of the properties above, we see that the congruence of triangles is an equivalence relation. It would be difficult to establish that triangles were congruent if 6 pairs of congruent parts had to first be verified. Fortunately, it is possible to prove triangles congruent by establishing fewer than 6 pairs of congruencies. Postulate 12. If the 3 sides of one triangle are congruent to the 3 sides of a second triangle, then the triangles are congruent. SSS. The designation SSS will be cited as a reason in the proof that follows. The three S letters refer to the three pairs of congruent sides. In other words, side, side, side. Given line segment AB and line segment CD bisect each other at point M. Line segment AC is congruent to line segment DB. See figure 3.4. Prove triangle AMC is congruent to triangle BMD. Proof. Statements. Reasons. Statement 1. Line segment AB and line segment CD bisect each other at point M. Reason number 1, given. Statement number 2. Line segment AM is congruent to line segment MB. Line segment CM is congruent to line segment MD. Reason number 2. If a segment is bisected, the segments formed are congruent. Statement number 3. Line segment AC is congruent to line segment DB. Reason number 3, given. Statement number 4. Triangle AMC is congruent to triangle BMD. Reason number 4, side, side, side. Note 1. In steps 2 and 3, the three pairs of sides were shown to be congruent. Thus, SSS is cited as the reason that justifies why triangle AMC is congruent to triangle BMD. Note 2. Triangle BMD is the image determined by the rotation of triangle AMC about point M through a 180-degree angle. The two sides that form an angle of a triangle are said to include that angle of the triangle. In triangle TUV in figure 3.5a, sides TU and TV form angle T. Therefore, line segment TU and line segment TV include angle T. In turn, angle T is said to be the included angle for line segment TU and line segment TV. Similarly, any two angles of a triangle must have a common side, and these two angles are said to include that side. In triangle TUV, angle U and angle T share the common side, line segment UT. Therefore, angle U and angle T include the side, line segment UT. Equivalently, line segment UT is the side included by angle U and angle T. Informally, the term include names the part of a triangle that is between two other named parts. A second way of establishing that two triangles are congruent involves showing that two sides and the included angle of one triangle are congruent to two sides and the included angle of a second triangle. If two people each draw a triangle so that two of the sides measure 2 centimeters and 3 centimeters, and their included angle measures 54 degrees, then those triangles are congruent. See figure 3.6. Postulate 13. If two sides and the included angle of one triangle are congruent to two sides and the included angle of a second triangle, then the triangles are congruent. SAS. The order of the letters SAS in Postulate 13 helps us to remember that the two sides that are named have the angle between them. That is, in each triangle, the two sides form the angle. In example 3, which follows, the two triangles to be proved congruent share a common side. The statement line segment PN congruent to line segment PN is justified by the reflexive property of congruence, which is conveniently expressed as identity. Definition. In this context, identity is the reason we cite when verifying that a line segment or an angle is congruent to itself, also known as the reflexive property of congruence. In example 3, note the use of identity and side angle side as the final reasons. Given, line segment PN is perpendicular to line segment MQ. Line segment MN is congruent to line segment NQ. See figure 3.7. Prove triangle PNM is congruent to triangle PNQ. Proof. Statements. Reasons. Statement number 1. Line segment PN is perpendicular to line segment MQ. Reason number 1, given. Statement number 2. Angle 1 is congruent to angle 2. Reason number 2, if two lines are perpendicular, they meet to form congruent adjacent angles. Statement number 3. Line segment MN is congruent to line segment NQ. Reason number 3, given. Statement number 4, line segment PN is congruent to line segment PN. Reason number 4, identity, or reflexive. Statement number 5, triangle PNM is congruent to triangle PNQ. Reason number 5, side angle side. The next method for proving triangles congruent requires a combination of two angles and the included side. If two people each draw a triangle for which two of the angles measure 33 degrees and 47 degrees, and the included side measures 5 centimeters, then those triangles are congruent. See the figures below. Postulate 14. If two angles and the included side of one triangle are congruent to two angles and the included side of a second triangle, then the triangles are congruent. ASA. Although this method is written compactly as ASA, you must be careful as you write these abbreviations. For example, angle side angle refers to two angles and the included side, whereas side angle side refers to two sides and the included angle. For us to apply any postulate, the specific conditions described in it must be satisfied. Side side side, side angle side, and angle side angle are all valid methods of proving triangles congruent, but side side angle is not a method and cannot be used. In figure 3.9, the two triangles are marked to show side side angle, yet the two triangles are not congruent. Another combination that cannot be used to prove triangles congruent is angle angle angle. See figure 3.10. Three congruent pairs of angles in two triangles do not guarantee congruent pairs of sides. Given line segment AC is congruent to line segment DC, angle 1 is congruent to angle 2, see figure 3.11. Prove triangle ACE is congruent to triangle DCB. Redraw. Proof. Statements. Reasons. Statement number 1. Line segment AC is congruent to line segment DC. Reason number 1, given. Statement number 2, angle 1 is congruent to angle 2. Reason number 2, given. Statement number 3, angle C is congruent to angle C. Reason number 3, identity. Statement number 4, triangle ACE is congruent to triangle DCB. Reason number 4, angle side angle. Theorem 3.1.1. If two angles and a non-included side of one triangle are congruent to two angles and a non-included side of a second triangle, then the triangles are congruent. AAS.